Okay, so recapping our mnemonics from this lesson. The first one we discussed is our bar plot, a really simple plot. We usually use it to summarize summary statistics, and we want to compare those summary statistics as well. Kind of like the three candles on our plot, really a simple three, very summary statistic, and we want to use our bar plot in the same way to really highlight simple summary statistics. And we could use the patches argument, and we'll see that in the workbook, to do cool things like highlight the outside of the boxes in our bar plot. We looked at a line plot. And really line plots are can be used in lots of different ways. I would say the most common way is to use a line plot to look at a value over time. And really you're trying to determine if really the relationship, the trend over time, and how that's affected, how that affects those two distributions. It's really simple. And so that gives us the ability to maybe plot many categories or many different features together as well, even within reason. But it still can be helpful in inspecting our series over time. We discussed the histogram plot that really focuses on removing and allows us to control how much, but removing the noise from our distributions. Do we want to remove more or less, and kind of simulating the effect, if we can kind of target this properly, to remove the or to kind of simulate the effect of having more data, right? So removing the noise from having a small sample, and we're able to plot this quite nicely and effectively. We talked about the KDE plot that allows us to, one, generalize a lot. It works in the sense that it's almost like a moving average, in that it gives us the outline of the distribution, and it's smoothing the points where there's no data. We can turn this down, the smoothing part of this algorithm, to allow us to see a lot of detail, a lot more detail. I usually turn it down a little bit, maybe not so much as we see. You can turn it down quite low, and it does look quite busy, but you can find usually a right amount to give a detail about the amount of data, but also give you some simplicity in the distribution and allow you to do things like compare many categories together. The box plot is a classic one. We've heard a little bit about this already. And so it's the interquartile range in the middle, and then 1.5 times outside of that is our classic definition of an outlier. And this box plot really generalizes the whole distribution in favor of highlighting the outliers. Okay. We talked about, and we can control the whiskers in the Seaborn box plot. We can control the size of the whiskers, how far out or close those go. So we have a little bit of control over what outliers we'd like to highlight in our box plot with the control of the whiskers. Okay. We talked about a violin plot, and really I find one of the best ways to use this is where we're highlighting two different categorical distributions on either side. So how do the category change the distribution? And our eyes are geared towards noticing symmetry. So when there isn't symmetry, it's very clear to our eyes and allows us to inspect this at a high level of detail. Okay. We talked about the boxin plot. And really it's kind of a hybrid of the histogram and the box plot. It does the interquartile range in the middle, but then it allows us to see a little bit more detail of the tails, whereas the box plot just kind of generalizes that with the line and the whiskers. Okay. So it really allows you to see a lot of detail in those tails, and I find it as a better alternative than using the box plot for even outlier inspection, because it kind of allows you to still focus on the outliers, but you're still able to see how you evolved, how that tail evolved to that outlier. It gives you a little bit of hint of really where you should be defining the outlier. We talked about the swarm plot, which really just lets you see so much detail. And so where lots of the other plots we talked about generalize the distribution in favor of almost simulating what this data, a small sample or a smaller sample, would be like if we had access to the population. Swarm plot does the opposite. It allows us to see really as much detail as possible in favor of putting every data point not on top of each other and trying to really spread them out as much as possible. We really see how the data is led. It really hides nothing. I found a lot of kind of interesting insights from this, and so it is a really good plot. It's something that you want to do in a more targeted way. You probably don't want to do this on everything because it can be quite busy, but when you find a distribution that's of interest, this is a really good one to use to really get in there and inspect in the most detail to find things that might otherwise be unseen. We talked about the count plot, and that allows us to compare frequencies in our data. It allows us to understand the balance of our classes in our category, and understanding the balances will relate to which categories, which classes of our category are we capturing more in our statistics or our correlations or mean. If we have more of one class than the other, we're really that is more representative of the one that is the category that is represented the most in our data set. We talked about the displot. This is really focused on exploring your distributions in a lot of detail and by categories. You can go sub categories and really start to at a very granular level inspect your distributions, and really noticing if there are any distributions worthwhile to inspect a little bit further to understand better and really understand how these categories play into this distribution. Okay. Another one of this, that's the figure level plot that allows us to do that, and another figure level plot is the cat plot, which really lets us get to know our categories. We can generate the same with these two plots, but lots of the same things, but the category plot, the cat plot, is more focused on the category inspection. The dis plot is more focused on the inspection of our distributions. They have a few different arguments to allow us to do that, although lots of the things that we can do are the same. So we use a lot of mnemonics in this class, lots of fun pictures and stuff. They are unique, illogical, and I use colors to kind of attach and connect things back and forth. The point is they are weird images, but that's actually the point. That should help you remember things, because our brains remember things that are illogical and weird. So the more we pay attention to that should help. We did use color association, word association, use visual space kind of when I was talking, 3D space, because that our brains just work better in a 3D space type of environment, and that's just from evolution. That's how our brains think. And so we talked about this. Really what I would love for you to do is go back and review, or as you're going through these videos, review the little bit of stuff that I have on the side, read a little bit more detail about this, expand your knowledge while we're talking about this, and connect it to the images, and then come back to the presentation that you can download and just review it. Just take a little review and just go one or two times through this. Will really help lock these concepts into your mind and really make it a lot easier to access. And as you can see, there are a lot of plots. They all work in different ways, and not there's a perfect plot for every situation, but you will find that you feel that you can get better things out of certain plots in certain situations, and generally there are some better plots and worse plots in most situations. So understanding how keeping all of them in mind is tough. It comes with practice, but hopefully this will help lock these in your memory, so it's a lot easier to find your way back to the knowledge that we discussed in this class, and then all of the arguments that go along with all these plots. So I'll see you in the workbook for the last section of this class.